am your presenter. I'm Sergio Leab. I am a consultant with SharkNet. Today, I'm going to talk to you about visualization data with Python. So before we start, I want to kind of like get the all expectations into the right frame. So you know what you're going to get. So what is this not about? So we are not going to go in depth the tutorial visualization. Here we will see just multiple different ways simple ways to visualize data. This is also not a programming crash course. So it assumes that you know some Python basics. And it's not a comprehensive list of visualization techniques. So that would take significantly longer than what we have. But what it is about, so this is a rapid visualization data. We're going to identify where or how to look for information. And we're going to show you a world beyond ggplot. ggplot is a package that is often used to plot data in R. And I'm going to also introduce you to basic dashboarding, so you can actually show your data in a more efficient manner. So let's start with the data set. I'm going to use a very widely used data set. Why is that? Because a lot of people know a lot about this data set and is readily available with most packages. Okay, so this data set in particular is the iris data set that was collected by Ronald Fisher in 1936. Is 3 species of flowers, and they have the width and the length of the petal and the sepals, and that is an interesting classification problem, as you can actually use it to classify these 3 species. We have 150 samples and 50 samples of 3 different species. One is setosa or iris setosa, versicolor, and virginica. Yeah, so this is the data we have. We're going to visualize a little bit. So as I was mentioning, we have this is a Python notebook. This particular notebook that I'm going to be teaching with is not going to be available, but I'm going to, in the comments and in our page, we're going to have a document version of it, so you can actually get all the steps and you can retrace what we saw during the webinar. So how can you load the data set? Okay, so the first thing that we want to do is to load the data set. So you can load it with your favorite way, but I'm going to load the data set that is already there, which comes with scalar, right? So scikit-learn. So you're going to start by importing the loading function. Okay, so if you do from scalar datasets import load iris, this will add this function to our environment, and then we're going to be able to actually read it directly, right? I'm going to also use a very handy library, which is pandas. So I'm going to import pandas as PD. Okay, and then I'm going to actually read the data. Okay, so data is going to be equal to load iris. All right, and then I'm going to put that data into the data frame. Okay, so I'm going to put df, and then I do pd dot data frame. So as you can see, this data frame, if you're not familiar with it, this data frame is a function from pandas. It's a function from pandas that will create a data frame. Now we're going to pass the data. The data is in a JSON format. So we're going to do data.data, we'll pass it directly. And then we want to organize it how we want it. So how do we want it? We want that the columns is equal to the features. So we do that feature names. Feature names, okay? So if we visualize this, so we want to see the, my bad, head. So if we see the thing, we see that we already actually loaded into a data frame or a matrix, however you want to call this. But we would like to add some other stuff. First of all, we don't have any information about the species or anything. So let's add that part, that piece of information. So First, let's translate the clustering that we have, because if I show you data dot target, which is right, so data dot target, as you can see, is just a vector of the classification per each species, and then if you go to target names, is going to give you the actual names of each one of the targets or each one of the clusters. Okay, so let's add this thing in a way that we can understand it better in a data frame. Okay, so first of all, we're going to generate the correct names. Okay, so the correct names are going to be like create a dictionary first. We're going to use zip for that. Okay, and we're going to go, we know that the names of the clusters are 0, 1, 2. So we can just create a 0, 1, and 2, or you can use a range, however you want to proceed with that. And then data dot target names. And I'm going to explain it in a bit of depth in a second. So names is going to be a dictionary that just maps the cluster name with the actual species name. And we're going to use this to translate what we have and add it to our data frame. Okay, so now we're going to do that. So we're going to tell the data frame, okay, I'm going to call this one in species, right? And this is going to be names. And then I'm going to do X or I or whatever you want for X in data.target. Okay, if I reveal the head of this, then I'm going to see that I just added each of the species for each one of the samples. So you're going to have the description, a nice description there. Now, all of these things that I've done here basically is just playing with pandas. If you want to see more information about pandas, I strongly recommend that you just visit pandas. Actually, is just pandas.pydata.org. Like, they have a lot of information and a lot of documentation about everything they do. As I mentioned it originally, this is not a crash course for pandas or any programming. It's just to kind of like give you an idea of what you can do with Python in your data. Okay. So this is our data set. So we're going to have sepal length in centimeters, sepal width in centimeters, petal length in centimeters, and petal width in centimeters. And we're also going to have our species names in one of the columns. So let's start with exploring what we have. So we already know that we have that in a table. So the table is 150 rows, and it has a bunch of different features, but how can you actually just get a sense of it real quick? So pandas have a lot of really cool visualization ways to, very easy, more than cool is they're very easy. So for example, if you do df.histogram, like hist, this is going to actually plot a little matrix of your of the features that you have. As you can see, so I'm going to actually, before I do this, I'm going to comment this out and bring back the head of this. Remember that we have all the features right here and species, but if we actually plot this, this is only going to plot the numerical values. So no categorical values are going to be plotted unless they are, the categories are encoded in numbers. Okay, so this is a very important bit to get. Now, these are going to be split by each one of the features, but let's imagine for some reason you actually want all of them in a single plot. Well, you can do that also natively in pandas. So if you do plot, instead of doing histogram directly, you do plot, and you pass to plot kind equal histogram. Note that is a string, so you have to quote it. Okay, if you do this, it's actually going to put everything in a single plot that you can see and check what is the frequency of each one of the things. Okay, now Again, I'm not going to enter into many details, but Plot has a lot of options, from figure size to modify your X and Y axis, etc., etc. We're not going to do a lot of that right here. Now, this is kind of like, because they are superimposed, it's kind of like difficult to see, okay? But you can actually change this. Instead of a histogram, you can translate it into a density plot with the KDE. So if you do KDE right here, it's going to actually, you can see the distributions without being overlapping. And this is a really easy way to kind of like get a sense of how your data looks like, what is the features that you have, and how much overlap between them there are. But oftentimes we want to do other kinds of things, right? Again, I'm going to use the base exploration for this. Let's imagine that you don't want actually to see the distribution like that. You want to see a box plot. Well, you can actually, if you do box plot, oh, sorry, I think it's just box. Yeah, so if they're just box, you can also see the distribution, but in a box plot format instead of density. The X axis here can be modified later on, but like for exploration, it's pretty handy to have the plot right into your built in into your data frame. Okay, and there are many others that I'm going to show. So area for this particular data is not very informative, because you just have a continuous variable here and then a continuous variable there, and it tries to feed everything into it. But if you have a time series or things that can be actually be plotted, like the index of the data frame means something to you, then area can be very, very helpful to also visualize your data. Although if you can see in this particular plot, about 50, we have a change of pattern right here in all the three plots. And in here, about 100, we have another one. So we are actually seeing the differentiation already between the three species. So area can be an easy way also to get a really big sense of how your data is distributed. This obviously is like that because it is organized by that particular feature. So if it's not organized, you're going to have something a little bit more juggle. Okay. There's another interesting plot, the hex bin. Oop. I think I need to provide an X. Sepal length in centimeters. Oh. And a Y column. And I'm going to give
spelling of length.
Oh, thank you very much. Yeah, but I think I also need to provide the Y here. So I'm going to do sepal width in centimeters. And what the hex bin does, it creates a pixelated version by hexagons of the density of the number of points that you have in that particular X and Y alignment. Okay, so it can be interesting to see if your data actually has a two-dimensional structure to it. Let's say that you have a Petri dish and you're analyzing images, or you're analyzing colony count, or etc., etc. As you can see, I keep referring to biology stuff because I am a biologist, I'm a bioinformatician, so that's what I do. Okay. Now, there are other ways to visualize and that are more useful, right? And it's when you want to cluster things or to use the categories in different ways. So for example, let's imagine that we want to know how many species we have how many samples of each species we have. So we can actually use something like the group by from pandas, right? And then we're going to call it species, right there. And then we're going to call it count. So when we do that, counts, this is going to basically give us this thing. Like in this case, in our data set, it's kind of boring because we know that everything is just 50. But this will allow us to showcase things like bar charts. So if you have, for example, count dot plot, I'm going to do AX count dot plot, and then you're going to do a kind equals bar counts. Then you can see it again. It's boring because you're just going to have everything is at 50, but you can get a sense right away, a visual sense of how many samples you have at in each thing. You also have the option of bar H, which is just to flip this plot into a horizontal bar graph, or I recommend you don't use this one, but you can also create, for example, a pie chart. So you can use pie right here. Let's do subplots equals true because we want to see them all in stacked. So if you do this, let me modify the figure so you can actually see it. So you can actually have a pie chart. And why did I say don't do this? Because pie charts are not the best way to visualize data. There are plenty of even articles written about it. So it's not a very good way to visualize data. But for your own exploratory analysis of the first kind of like pass of it, you can actually get into it. So yeah, so give it like there are many information about this visualization. If you go to Pandas and check for visualization in their webpage, you will find all of these kinds of visualizations that I just mentioned. And it is going to be connected to the API, so it will tell you also all the possible options that you have to modify your plots. Okay, like for example, in this case, we use subplots true to avoid having them stack vertically and put them in a single thing horizontally. And we can modify also the fixed size or etc. etc. We will see some brief modifications later on. So we already saw like how to explore your data, the very basic way. We saw also that Pandas have a lot of options already. We already saw group by, which is that it will create groups by a particular categorical variable that you will have in your data set. Now, what if you want to plot these things per species, for example? So something similar to what we did in the bar plot, but like the distribution. Let's say that we want distribution by species, not just by features, but by species. So what we can do is we can create a plot with the group by. So let's start with the group by. Then you're going to group them by species, right? And then you're going to call plot on it because this is going to give you an instance of group by, right? So like actually, let's show it to you so you can see it. So if you do this, it's just going to give you an instance. It is its own thing, okay? So access, but that instance have a function that you can call. So you can actually call directly plot to it, and then you can use some of the plots that we already saw, okay? So for example, KDE, which is, in my opinion, one of the most useful to see the distribution of your data. Let's modify fixed size just for the sake of it. As you can see, fixed size is always comes with a tuple or a list that you're going to give width and length of your plot. Okay, so in this case, you can see that each group got plotted into different plot of its own. Okay, now this one doesn't tell you much because you really don't know which species is which species. Okay, so we will need to introduce you to another package, which is actually used under the hood by Pandas, which is Matplotlib. Is the basic plotting engine in Python, is used for most of the others that actually do any plotting. They already use Matplotlib to extend the functionality. So first we're going to import it. So import matplotlib.pyplot, right? As PLT. Right? I like shorter versions of this. Then I'm going to create some subplots. Okay, so I'm going to create a figure and some axes, right? And then I'm going to go plt.subplots, and then I'm going to give some information about how I want this arranged. So I'm going to tell it n row equals 1. So I just want everything in one row, and n col equals 3. Okay, and then I'm going to do that share. They don't share an x, so I'm going to do share x equal false. And then I want them to share the y. Okay, so I'm going to use true in this case, and I'm going to show you how that looks in just 1 second. And then fig size equals, let's make it 20 by 5. That's the thing. Yeah, and then I'm going to create for that subplot, I'm going to use a subtitle. And then I can actually go over each one of the groupings, okay, and the axes that we just created right here. So I'm actually going to remove this one for now, so I don't create more confusion. So I'm going to go over the groupings that we already have. Okay, so how do I do that? I'm going to do for AX or axis, right, and name and grouping, and you'll see in a second this in zip. So what zip does, it kind of like creates pairs or two different lists or iterables in general. Okay, you're going to pair the first one of one with the first one of the other. So what I'm going to be pairing, I'm going to be pairing each one of the axes that I just created here, right? This is going to create basically 3 axes because we only have 1 row and 3 columns. So that will create 3 axes or 3 subplots. So this is what the axis is doing. And I am going to zip it with a group by. So I'm going to do df group by species, like this. So what this is going to be creating, this group by will unravel into 3 different things because we have 3 species. Okay, so each axis is going to be matched to 1 species, and each group in the group by will have a name, which is going to be the name of the species and the instance of the group to be able to plot. Okay, so when we do this, then we can actually use group to plot, okay, the kind that we want. So we want a KDE, right? And now we need to provide also an AX. So in which axis we want to plot. So once it's always spellings. No, it's not that. Okay. Yeah, I think it's in calls and rows. Little tiny details that it always creates little issues. Yes. Okay, so as you can see, when you fail, or when you have a typo, or you forgot to how to call a particular thing, it will tell you that there's something wrong, and you can actually review the traceback and fix whatever you were having. Okay. So whatever issue you were having. So now we can have actually each plot per species. Now still I cannot see it here, right? So I'm going to be fixing the legend. So we already in here we already plotted each one of them, but I want to fix the legends. So A, they're not repeated, and B, we actually have some titles in each one of them, so we can know which species is which, etc., etc. So how can we do that? The lazy way, and I'm going to go to this one because I think it's better if I just have that right there. Now I am going to use in each one of these, I am going to add the plot title, for example. So for example, if I do here, thing is title equals name, all of a sudden I already have the titles right there. So I know which one is which one, but also I can remove the legend from it. So for example, if I do legend equal false, so I can remove the legend and then place it later on with the in the full figure, PLT legend. Right? So only one have it, and then I can start moving the legend however you want. So I'll recommend, because we already halfway through the seminar and I want to keep going, so I recommend you check how to move legends later on. But then we have a single figure with each one of the species. They are split. They each one have its own density plot, which have all the features that the dataset has. Okay. Okay. Now, changing the style is actually super simple. So I had this already here to fix the legend. The only thing that you need to change is plt.style.use. Let's imagine that everybody wants ggplot, because a lot of people want ggplot, and that's it. With this, we already going to have this. So let's walk it through. PLT style will use different styles of plotting. So basically is the defaults that you're going to use. What's the background? If you have a grid, what kinds of colors, the color palette, all that stuff is already going to try to mimic ggplot. So that's our win. Now in here, we created one row, 3 columns. Again, the same. We're not sharing X, but we do share Y. So the density is the same for all of them. What would happen if we don't do this? So if we set it to false, for example, so if I set it to false, you're going to see that each one will have their own density, and they're going to be more difficult to compare because you're going to have to see that the units are different. But if you put true in here, then all the units are in the same, the Y units are in the same scale. Okay. Now in here again, so we're going to go and loop over each group and axis that we just created right here. We're going to plot without the legend, and then we're going to get the legend handles so we can actually modify it. And this way it will put the legend, figure the legend out for you once you do this. Okay, so the legend is outside. It is a lot cleaner plot. So now comparing groups and features. So now we've been plotting with groups, but we probably would like to see how can we actually split the groups and the features and try to compare them. Okay, so one way what we can do, for example, that is very used in science is simple linear regressions. Okay, so we're going to generate a linear regression and we're going to plot it for some of the features. So let's import Matplotlib again. Then we're going to use scalearn to do the linear regression. So we're going to say from scalearn dot linear model. I think it's like that. Yeah, linear model, import linear regression. Okay, and let's do again plt.style.use ggplot. I'm using this just for you to keep remembering, but since in the notebook is already there, so I actually don't need it, but I don't want to confuse people. Okay, now we're going to create again a set of subplots. So we're going to do fig and axis, and we're going to do plt.subplots, and then n rows equals 1, n cols equals 3. So basically the same that we've been doing, char x equals false, char y equals true, and then a figure size of, let's say, 15 by 6. And now let's going to, again, we're going to do the loop over these groups, and we're going to do the linear regression per group. Okay, so we're going to do for AX or axis, and then name and group. Oh, Jesus Christ. And group in zip, then we get axis, and then we get df dot group by species. Species. Yeah. And now we're going to do the linear regression. So linear regressor is going to start. We just need to initialize it. So we do a linear regression. And now we're going to get the X and the Y just to be organized. So we're going to do group, and let's just start, or let's just do sepal length in centimeters. And we need to make it fit the linear regression. So to do that, we just do values, which you will return a single NumPy array, and we need to reshape it from -1 and 1. Okay, this is just to put it in the right configuration for the linear regression to read it. And we're going to do the same. I'm going to actually copy this, because it's exactly the same, but with width. And now we're going to actually do the linear regression. Okay, so we're going to fit the linear regression. So linear regressor dot fit, and then X and Y. And that will generate an intercept, right? So if intercept, the intercept is going to be in the linear regressor. So linear regressor, I think is intercept underscore, and then 0. I'm going to put this here. And then I also want the slope. And what I want this is because I want to also plot oh, this is coefficient. To also be able to plot the actual formula that the regression will give me. Okay. Now, once I have all the regression for that particular species in those two particular features, then now we can get to plotting. So we're going to do group, and in the group, we're going to do group just plot. And then we're going to tell it to plot X is going to be the sepal length. So it's going to be this one, sepal length, and then sepal width is going to be the Y. And then I can the kind. So I want it in a scatter plot. So it's going to be scatter that I have not shown yet. So it's a good thing. Then AX is going to be the axis that we are going to get from here. And we can add a title. So the title is going to be the name of the species. Now we also want to get the line right there. Okay, so we're going to use the axis and we're going to tell it to plot. Plot is normally line plot. And then I'm going to tell it X and Y pred. Although I think, linear regressor, fit. I need to predict it first. Sorry about that. My mistake. I need to predict it first. So pred, it's equal to linear regressor dot predict, and I'm going to predict Y based on X. Okay. So when I go to plot this, and then I also going to do this AX legend just for the sake of it. And let's see what we get. So it's going to give you the not handles found in the legend, just because you actually did not have anything you didn't tell anything to the legend part. You cannot see it. I thought I fixed this thing, but apparently not. So I'm going to just remove these ones since we already have them. Actually, let's just remove so you can see. So you can see actually the particular line that we had. I'm going to add something to it so we can actually see the formula that we get. So we're going to add to this plot that we just have here. We're going to say, okay, the color is red, although it's already red, but you can actually put the line of the color you want. And also you can add a label to it. So let's label it, that is going to be Y is equal to, and I'm going to put this here, 0.2. So I'm going to explain to you in a second. What does that mean? Plus 0.2 f x dot format. So what I'm doing here is formatting a string. So what I'm going to pass to it, this is going to be expecting a float, which comes from whatever it is that we're going to have here. And then in the format part, we're going to pass it. So first in the intercept, and then is the slope. Okay, so this one is going to pass it right there, and it's going to pass it as a label. So as you can see, now you can, I'm going to remove this just so you can see the plot. You have the actual model that you were plotting from, and you can see the relationship between sepal width and sepal length in each one of the things. Okay, so okay, now oftentimes you want to actually save the plots, so it's easy. So and then the file name that you pass here, actually you can pass whatever, PNG or PDF or JPEG, etc., etc. Okay, so it will actually, just by the name of the plot that you pass, is going to give it the particular encoding that you want. Okay, so this is how it works. So let's go PDF, and this is going just to save the figure of particular size. Okay, so take a look. You can also change the DPI if the figure corresponds to a DPI thing, add metadata, a bunch of stuff. So take a look of how you want to save your figure if you want to save it. Okay, there's a little easier way, or prettier way, more than easier way, to compare features with other package that is based on Matplotlib, but it actually like it extends the functionality, which is Seaborn. So I'm going to import Seaborn as SNS. And again, as I mentioned in the original and at the beginning of the webinar, there are many plotting things. Plotly is one, Seaborn is another. There's many different plotting things in Python. Seaborn is just one of them, but I don't have the time to actually show it to you more than a couple. Pyplot as PLT. Okay, now I'm going to do sns.lmplot. LM stands for linear model plot. And then you can pass x is equal to the sepal length in centimeters. Y is going to be the sepal width in centimeters. Then let's say that the column is going to be the species. And you need to provide what the data is from. So our data is actually our data frame that we have. Okay, and this, Matplotlib, and this is going to create nice plots that you can actually modify. You can set themes, for example. So if you do SNS dot set theme, and you can say like color codes equals true. This will modify the hues that you're going to be using to a different color, etc., etc. Is going to give you each one of the classes that you pass by the column, and is going to give sepal width and sepal length as both of the things. So it's very easy to say. You can also use the Seaborn has a lot of extensions to Matplotlib. One of them that is also very handy is the Violinplot. So you can actually just do Violinplot. And you can pass, you need, for Violinplots, of course, you need to pass a categorical variable in X. So species, then the sepal width, and then actually this one doesn't have any code. And then if you do this, it's going to give you a Violinplot of one particular one and each one of the species. You can, again, use exactly the same that we did before for groupings. You can do it for Violinplots and have one Violinplot per each feature, for example, etc., etc. So there are ways to do this. If you have multiple categorical variables, then you can also use Seaborn to plot them. I'm going to kind of like go into a more fast mode because we don't have too much time. So I'm going to just give it that. So I'm just basically here adding a collection date that doesn't exist in the original, but it's a way to show you two different categorical variables that we're going to be plotting into something that is called a Swarmplot. That I find it also very useful to display your groupings, right? So in this case, we pass the data again, X and Y. Y has to be categorical, and then the second categorical variable, you can pass it as a hue. So in this case, the hue is going to be dependent on collection day. Oh, I didn't import NumPy as NP. So because I'm using NumPy right here, so I forgot to load it before. So you can see how each species, each sample in each species are from which day. This is especially useful when you want to see if there's a bias in your data, in the sampling of your data. Okay. Now I'm going to go a little bit quicker in this one. If you want to see, for example, multiple dimensions in the case of PCA, we can actually create a PCA plot using a sklearn. So we just create the PCA plot, we feed it, and then we can actually see how much variance explain there is. And then you can actually plot the grid of all the things using a pair plot. So in this case, we're going to transform, like create a data frame with each one of the PC plot or the PC components and species as one of the columns as well. And then we're going to use a pair plot that the hue is going to be the species. This is going to create a really nice looking plot where each row is going to be one of the PCs, each column is the corresponding PC, and then in the first one, when it's the same one, you're going to see the distribution, and in the between, you're going to see both of them. Okay, but you can also use 3D plotting, so that's something that you can also do in Python. So if you, for example, I'm going to so if you use MPL toolkits, it's part of Matplotlib, but it's kind of like an extension of Matplotlib that does 3D plots, and you just use Access 3D. You can actually plot the figure however you want. Then add that figure, like this PLT is just basic Matplotlib, and then we can add the figure to an axis in 3 dimensions, and then you just get the colors. So when you plot this, you're going to have actually the 3 dimensions of the colors that you want per each one. Okay, so in here, what we did here, CMap, is just we took a color palette and we transform it into an iterable that we can then map to each data target. So each cluster. So 0 corresponds to blue, and yellow, orange, or green, etc., etc. And we can set the labels however we want it. In this case, I set it up to the explained variance. Okay, so that was V1, V2, and V3. In this case, it's a little bit different than we did before, because in here I'm using an F formatted string. That's a particular thing from Python 3.7 and up, that you can actually pass directly the variable names and do stuff with the variables right here in between the curly brackets. For example, in this case, I took the variance explained and I multiplied by 100, and then I displayed in a 2 decimal float. Okay. All right. I can add custom legend, but I'm going to skip that one just because I want to show you a little bit more of interactivity with a different package that is called Bokeh. Bokeh has the extra added interactivity, and I'm going to show you a little bit about it. So when you do this, so Bokeh, you can import output notebook just because we are in a Jupyter notebook. Figure and show is the one that are going to allow you to see the figure. The color map, we already talked about it. Then tooltips. Tooltips is a particular variable that will allow you to, when you hover over the points, it will actually create the collection day and species in this particular case. You can add a title and add the tooltips to the particular bokeh figure, and you can also add the axis labels. And then we're going to go through the species group by, okay, and we're going to be plotting a scatter plot using bokeh that contains the number of the name of the flowers and the color of them, etc., etc. So when we do this, this is going to just enable bokeh, and then we need to use ShowP. I put it in a different slide so we can see the theme better. So you can actually see Setosa, and you can actually see Virginica, etc., etc. You can actually go here and disconnect. You can modify the colors per species, for example, if you want, depending on how you create the map. So it is a very, very useful little interactive plotting. And it requires very few things, very few tips, okay, to give you. So where the location is legend, the click policy, this click policy, what it does is allows me to create a clickable legend. So if you can see, if I remove setosa, it's going to remove these points. If I remove versicolor, it's going to remove those, etc., etc. So this allows you to interact readily with the plot in a very seamless manner. Now, I wanted to show you how to create apps, which will be kind of like the tip of everything that we've seen so far, but I think that we are a little bit over time. So I'm going to, for those that cannot stay up for a little longer, this is going to be recorded and is going to be available in our YouTube channel. I'm going to share also in the comments of that particular video. I'm going to share the document version of the notebook, and also probably this notebook that is there. Okay. So for those that can stay for a little longer, so let's walk through an app. Probably will take me 10 minutes or so. So please bear with me. Okay, so we're going to do again about everything. So we're going to import pandas, import NumPy and Seaborn. We're going to get the data set. In this case, it's just because we need everything self-contained. Bokeh has a curdoc, which is the one that's actually going to create an HTML version of the plots, and it we're going to give you in a server. And then we can have layouts, so how we want to lay out the dashboard. And we have models, so we can have column data source. Div is to add HTML things. Select and slider is to allow different, let me put it over here, different widgets that you can actually interact in your dashboard. Okay, so the first part of your web app should be handling your data. So in this case, you're loading iris, you're creating the same data frame that we had. So this part is exactly the same as we had before. Okay, all of these have to be put eventually in a file that you then need to serve. And I'm going to show you that in just 1 second. Okay, so far so good. So we're just added a couple of imports basically from what we have done. Okay, then we will need to add some descriptions, for example. Let me. So you can actually add this a string with HTML in it, and is going to render in your particular dashboard. Okay, in the thing. Let me. Okay. Then the description, you need to render it using div. So when you pass to div is basically HTML. You pass the description of the text and you can stretch it, or it has different sizing modes. Now you can also create input control. So in this case, for example, we're going to create an input control that is going to have a species as the title of it, and is going to have options. Is going to have all, which is added right here, and then all the species. Okay, only unique values of the species. So that's why I'm passing this here. So this option is going to be a list that the first element is going to be all, and the rest of the elements are going to be the species. Okay, the days, I'm also going to add them in the same way, in the same manner, and you're going to see why they all in a second. Now, you can also add interactions with each one of the features. So in this case, I'm going to add an slider that you can actually, so it's going to be a ruler that you can slide up and down, right? That's going to have a value of 4, and it's going to start at 4 and end at 8, right? And you can give it step that you want, the false that you want, etc., etc. The same happened with petal and sepal widths and lengths. And then we're going to create a different selection of axes. You could possibly add multiple plots if you want. In this case, I'm going to show you to one plot, try to explore the entire data set. Okay, so in this case, x-axis and y-axis is going to be all the numeric types of my data frame. So that's basically going to be sepal and petal length and width. Okay, by default is going to be the sepal. So I'm going to start. Oh yeah, like I already have it in my in a file. And finally, oh no, sorry, there's a couple more before I can show you the functionality. So okay, so then I need to tell Bokeh, I need to tell what the source is. So I'm going to start with an empty source. It's a column data source. The data is going to be a dictionary that is going to just have X, Y, color, the species, and collection date. Okay, that is how you're going to start it. And you're going to see how it gets populated in just 1 second. And then the tooltip is the same as the interactive bokeh that we saw before. Okay, now we're going to generate the first figure, or the raw figure, which is going to be a figure with no titles. You're going to give it some tooltips, sorry, some sizing, basically similar to what we did before with the interactive plot. And then I'm going to add a circle plot, which is basically a scatter plot, where X is going to be this X of the source, Y is going to be this Y of the source, and then the source is going to point to that particular one that we want. Okay. Then I can set the sizes of the circles, the color of the circles. In this case, the color is going to be referencing the source color. And then you can add line color if you want. Now you can create functions within this particular app that will allow you to select, to subset what you want to show. Okay, so in this case, for example, you're going to get species value, days value from the species and days select boxes, or drop downs that you're going to see. And then the selected, then you need to subset your data frame with whatever it is that you put here. So sepal length value is going to be the result of the sepal length slider. Okay. Same with width and petal width and length. And then we need to add an extra if. So if species value, so if this one is equal to all, since it doesn't exist in the data frame, you will need to subset it, saying just basically, if it's not all, subset it to whatever the value is. Okay, so in this case, what it's going to be doing is it's going to take the species where the species value is exactly equal to the whatever we selected in the drop down menu. Okay, and lastly, I'm going to put that here just to show you. Lastly, we need a way to update it. Okay, so I'm going to take this one off. A way to update it. So basically, this will call the select function that we just did, and is going to take, okay, what is the value of the x-axis, the y-axis, and then set those axis names as they are. So in P axis label, then it's going to select the title. So you can put a title, and set the source data as it will be with any update that we do. So every time that we click in something, this update is going to be run, and is going to subset your data frame and plot the data frame that you just subsetted. And then we need to set the controls. So the controls are going to be all the things, the drop-down menus and the sliders. So we want species, days, and sepal width, petal width, all that stuff that we already set it up. And then we need to loop over them. So, and tell them what to do on change, right? So for each control, we're going to take the value is going to change from all to new based on update. So based on this particular function, so it's going to call it per each control section. Okay. Now it comes the display of how you want to display it. So this is going to be in columns. So in columns, all the controls are going to be in the columns, and the width for the controls is going to be 320 pixels. And then you're going to add an extra column with the description that we had before. And we're going to get a row with these inputs that we have here and the plotting. Okay, and then we're going to, there are many ways to scale that so it checks everything. Then you need to call update once just for the initial load of the data. And then you're going to use CurDoc to add everything to that HTML site that we're going to serve to the web. Okay, so that's done with CurDoc add root, and then you pass the L that you just the setup that you just have here, and the title can be the title you want. Okay, so now once you have that in a file, so if I do cat my app.py, you're going to see that the file has all that thing that we just talked. We will need to actually use Bokeh serve and then my app. If you pass show, as I'm going to do, is going to open the interactive thing. Oh, I'd open it in a different thing, which is right here. So you can see local host is because I'm running it locally and is running my app. And then you have a drop-down menu that is going to modify what are you having. You can change the collection date, you can change the minimum length or minimum sepal length, etc., etc. You can also change to pedal, and you can change the comparisons that you want to do, etc., etc. So this is actually a really nice and easy way to do a more complex visualization or explanation of the data. So with this one, for example, you don't need to create such a big presentation. With one dashboard, you actually got all the data you need. You have some hovering. You can actually interact with this particular data dashboard. With that being said, I had an extra thing that is going to be there for you in the thing, which is Streamlit, which is a slightly different way to do dashboards, but it runs very similar to the Bokeh I show you. So, but I am already a little bit over time. So I'm going to open for 5 minutes of questions. If you want, please unmute yourself and ask the question, ask away.